Today is November 4 and I'm actually very late sa Halloween party. But I'm just gonna in this video I'm gonna share to you a very scary na story, A scary story na would probably imply that our known universe might not be real. So, okay. Okay, so I'm going to start with I'm going to start with a story now. Starting way back in 1650. So that's like 400 years ago. About 400 years ago. So si Isaac Newton. Okay. Ito yung picture ni Isaac Newton, no? So si Isaac Newton is a English na mathematician. He's also a physicist and an astronomer. So siya ang parang father ng classical na physics. Siya ang nagturo or nag-open ng idea sa mundo na ang mundo ay deterministic. Na tawag dito, when you throw a ball, you can predict where the ball will land, given na you exert a force to throw that ball, no? So it opened a lot of applications and technology sa idea na binigay ni Isaac Newton. So nagawa natin yung mga mga rockets to fly to outer space. Nakagawa tayo ng mga cannons way back, cannonball. So ang daming application ang na-contribute ni Isaac Newton. So eto mga example na nabigay niya sa mundo. Eto example ng ball. So a lot of mathematical formulas, no, which I am not even familiar na kasi very long ago tong mga ganito. Siguro high school, 4th year high school. So, hindi na siya familiar, no? So, ito yung naibigay ni Isaac Newton na contribute niya sa mundo na very deterministic. We can determine where the ball will land using mathematical equations. And eventually, we translated that into something na mas bigger pa. So, with Newton and Kepler na lang din, we can predict where the position of our planets are and where will it go in many years to come using Isaac Newton's law or mga mathematical equations ni Isaac Newton. So, you can say na Isaac Newton is focused on the big things na nag-i-exist dito sa mundo. When you throw something, it's a thing, it's big, we can see it. Isaac Newton deals with that. Now, many years have passed, nagamit yung ideas ni Newton. Along came Max Planck. Si Max Planck naman is a German na theoretical physicist. Nanalo siya ng Nobel Prize in Physics in 1918. So, imagine, 300 years have passed since Newton, So, si Max Planck na ang nag-originate ng quantum theory. So, siya ang father of quantum theory. So, ano ang quantum theory? Ang quantum theory is a theory that explains how the smallest things behave. Photons, electrons, and all. Mga smallest na talaga na even our microscopes can't even see them. Very tiny particles. So, yan naman yung gustong i-describe kung how they move sa quantum theory. And si Max Planck naman ang nag-originate niyan. So, paano gumalaw yung mga smallest bits, how it reacts with other smallest bits, so smallest particles. So, it's basically the same with Einstein's theory, no, but it deals with the smaller na mga smallest bits of our reality, of our universe, of our known universe. So, yun. Siya ang nag-start. And then, si Einstein naman, yung rockstar na scientist, is at that time ginagawa niya yung theory of relativity. So isa din siya sa siya actually ang nag-revolutionize ng understanding natin of space and time. And in a way parang siya pa nga ang nagpa-improve ng mga na-discover na ni Isaac Newton. So sabi niya, Isaac Newton's mga laws niya, mga mathematical formula is actually correct, but he says it's incomplete. And you will see na yung term na yan, you're correct, but it's actually incomplete. Is a common na theme sa science na even though incomplete siya, it still works. So example na lang kay Newton, sabi ni Einstein, you're incomplete, but you are correct. And until now, ginagamit pa din natin yung formula na ginamit ni Isaac Newton sa ating mga simple na mga ginagawa dito sa mundo. For example, in engineering and in our rocket science, ginagamit pa din si Isaac Newton. So, sabi naman ni Einstein na it's incomplete, kailangan nating dagdagan. Ito na yung theory of general relativity niya, which is a lot more beautiful compared to Newton's law. It described gravity, paano siya nag-behave, ano ang force niya, is it a force? Sinagot yun ni Einstein. So, it's a complement to the work of Newton. And mas nag-expand, mas lumawak yung understanding natin about the nature of our reality. So, ganito pala talaga nag-behave ang mga planets. Mas na-explain ang planetary movements ng Mercury. Kasi dati si Isaac Newton hindi ma-explain ng formula niya ang planetary na movement ng Mercury. So, with Einstein's new formula, mas accurate na, nasasagot na. So, yun. At his prime, siya yung pinaka-rockstar sa science na field. And nanalo pa nga si Einstein ng Nobel Prize in 1921. So, isa din na known si Einstein is siya din yung known siya for having a view. Ang term na gagamitin natin, which is ginagamit ng scientific community, is the locality view. So just keep that in mind na meron siyang view na ganyan, locality view. Locality means it's simple. It's locality means if you like clap your hand or make a noise or throw a ball, move something on your desk, it means ang epekto nito is just in my local environment. That's locality. Very simple, right? And hindi daw magme-make sense kang Einstein if I move something in my table and yung reaction ng paggalaw ko is nandoon sa Canada. If I punch in the air, may matatamaan na ulo sa likod doon sa Africa. So hindi pwede yon, sabi ni Einstein. That's locality. And it makes perfect sense, right? We observe that kind of phenomena in our known universe. It's a thing. So nobody can, walang pwedeng makipag-away doon kang Einstein, And to give context na lang din why it's a revolutionary na view, it's because way back prior wala pa tayong mga understanding. Like imagine having a view na when you jump off a building, lilipad ka kasi you have faith in God. Or when you cross a busy highway, or you for example wala pang highway dati, or if you cross this lagoon, hindi ka mamamatay kasi hindi ka naman kakagatin ng buhaya kasi may buhaya ba sa lagoon? Saan ang buhaya? Swamps, okay. So if you cross a swamp, you won't die because you have faith in God. So we have that kind of weird ideas in our head, and Einstein just put a stamp na, hey, locality, there's a reaction to every action, and the reaction is local. It's not magic. It's local. There's no like a special realm out there that is constantly looking down on us and will change the order of physics just solely for you. Ganun yung idea ni Einstein. Walang spooky. There's no spooky thing that's gonna happen. Walang supernatural thing that will happen. That's Einstein. Now, sikat si Einstein, 'di ba, sa classical na physics, the big things. Now, narinig niya itong quantum physics, and is also very heavily involved in it, no? And he reacted kasi naka-establish na siya ng locality na idea eh. Pero ang quantum theory implies that in our reality, non-locality exists. That's the implication of quantum theory. Remember, quantum theory is the theory of the movements, the mga actions or behaviors ng mga smallest bits of particle in our universe, right? Photons, electrons, and all. And quantum theory implies na, yep, tawag dito, non-locality exists in this realm. Things will happen instantaneously, even if that thing is galaxies apart. Galaxies apart. So, ganito yung parang implication eh. When you ano daw, pag pinag contact mo yung photon in this picture, for example, this is just a poor na visualization. It doesn't actually look like that, but just imagine that this is a particle, and that when they entangle daw, pag nag-interact siya, and when you split them apart even trillions of miles away, sabi ng quantum theory, it somehow made a when you measure the particle on the left, the particle on the right will react. It's as if they have this connection na will communicate na, hey, I was measured, do something on your end, and react as well. So parang ganun na even though trillions of miles apart sila, they can instantaneously communicate to each other. And that's non-locality. Kasi sabi sa locality ni Einstein, nothing can travel faster than the speed of light. Nothing can travel faster than the speed of light. So it is violating the locality view of Einstein. And Einstein was famously quoted eh. Sabi niya dito na sa letter niya, sabi niya in German yun eh. So the translation is spooky. Ooh, spooky. Spooky action at a distance. So how come? How come na when you measure the other one reacts, and ang nature kasi ng particle is, for example, if yung orientation niya is up, I'm just using terms ha, it's not actually orientation or it's not actually pointing upwards. I'm just putting a placeholder. So if ang orientation ng particle na nasa left is up, the other one is gonna be reacting to the opposite. So it's gonna react down. So it's downward siya. So it's never gonna be up. It's up and down, or down and up. Parang ayaw ni Einstein. Sabi ni Einstein nga eh, the theory is actually accurate. Nasasagot niya ang mga katanungan natin, na may application siyang naibibigay, may na-predict siya na accurate din, the results are accurate, but it's incomplete. Sabi ni Einstein na naman sa quantum theory. Sinabihan ni Einstein si Isaac Newton na you're correct, but you're incomplete. Sa quantum theory naman, sinabi din ni Einstein na you're correct but you're incomplete. Yun. So, let's just pause. Wait, not pause. Okay, let's continue. Sorry. Ito din yung parang orientation ng particles. Merong spin up and spin down. This is just an example. We put a label up if it's spinning like that, and down if it's spinning like that. So that's why it's up and down. Ang weird talaga ng mga scientists, even though it's spinning right and left, they put a spin up and down as a label. So that's them. So ganito yung parang yung visualization ng particle. And another weird thing, aside from the spooky action at a distance, may other thing din na ayaw ni Einstein din sa implication ng quantum theory. Another implication of quantum theory is that before you measure a particle, it is daw, sabi ni Einstein, sabi ng quantum theory, it's both spinning up and down. A particle is both spinning up and down. Imagine, can you see something na it's both spinning up and down? When you flip a coin, like ipapaikutin mo yung coin, di ba may direction lang na isa lang, na spinning right or spinning left, it looks like it's spinning right when you spin a coin. It looks like it's spinning randomly, but in actuality it's just spinning right, or it's just spinning left. So we don't observe in our reality that a thing does spin both left and right at the same time. Another non-local thing, sabi ni, not non-local kasi hindi naman yung reaction, but it's another weird observation implied by quantum theory. So si Einstein yun ang nagsabi. So yun, sabi yun ni Einstein na weird, why, how, it's that's an impossible thing. It's not both spinning left and right at the same time. There must be an explanation. And what else? So this one is Niels Bohr. He is a Danish physicist, and nanalo din siya ng Nobel Prize in Physics noong 1922. Siya actually ang prevalent na view ng quantum theory. So, Rika pa si Max Planck ang father, but siya ang parang nag-improve pa or nag-move forward pa ng quantum theory. And may view siya sa quantum physics na even pushed forward the idea of non-locality. So, siya pa ang parang pinush pa niya further ang quantum theory. So, si Einstein lalong na-bother. Lalong na-bother sa idea na 'yon. May sikat din nga na phrase sa Einstein eh. God does not play dice. Okay, sabi niya 'yon. So, in 1922, so siya actually ang nag-establish ng quantum mechanics. So, quantum mechanics is like the more detailed na branch ng quantum theory. Quantum theory is the branch ng science, pero ang quantum mechanics, it's like the more detailed thing. It's like establishing the actual law on how particles, the smallest bits of thing in our own reality behaves. So siya ang nag-establish ng quantum mechanics. So you can imagine at this time, Nobel Prize winner Einstein, Nobel Prize winner Niels Bohr, two equally brilliant scientists at that time, have opposing views about our reality, about the smallest bit of information in thing in our universe. Einstein doesn't like the idea of things communicating to other thing faster than speed of light, and he doesn't like the idea of a particle having a fuzzy state, both up and right or both left and right at the same time. There's like a debate, no, between Bohr and Einstein at that time, and nagiging prevalent na si Bohr sa quantum theory na field. Si Einstein naman gained support from other scientists. So Einstein submitted a paper called the EPR paper. So meron siyang kasama na scientist na si Boris Podolsky at Nathan Rosen. Yung papel nila explains sinabi nila na quantum theory is actually correct. It's actually accurate, but it's incomplete. And then sinabi nila doon na there's an explanation daw to solve the problem of the non-locality nature of quantum theory. So sinabi nila doon na yung fuzziness, it's not actually fuzzy. Sabi ni Einstein, it's not actually fuzzy. Or sabi ng the EPR paper, it already has a hidden value. So it already has a hidden value. When you discovered it, for example, balik tayo doon sa orientation niya. Sabi kasi daw ng quantum theory, it's both spinning up and down, but when you measure it, when you stop the particle from when you capture it, when you measure it, when you use a apparatus to detect it, parang siya, nagdi-decide siya na hey, I'm a kind of particle that spins up. So it will register na spins up siya. Even though ang kanyang prior state before we measure them is both spinning up and down. So sabi ni Einstein, nope, it's not both spinning up and down. When you measure it, you just discovered its nature. So nagmumukha lang siya nag-spin up and down, but in reality, if you measure it, it's actually spinning up. Sorry, medyo mahirap i-explain. Sorry, but ganoon. Let me give you an example na lang. For example, gloves, right? Our gloves have left hand and right hand. It's never a glove na both left and right-handed. So, it's like this daw ang particle. It appears, before you measure it, it appears like it's a glove that's both left and right. But when you open the box and see the glove, it's right-handed or it's left-handed. It's either the two. So, when you open the box and see it's right-handed, that means it was right-handed the whole time. It wasn't like both left and right na glove. See what I mean? So yun yung solution ni Einstein para ma-preserve niya yung locality na view, kasi ayaw niya talaga yung non-locality na implication ng quantum theory. So yun yung sinabi niya na when you measured it, it's right-handed or left-handed. That means prior to the measurement, it was right-handed the whole time. That's the solution, no, sa fuzziness of the nature of particles. And the other solution is they weren't communicating. The particles did not communicate faster than the speed of light. They are already in that orientation to begin with. They already are right-handed. So if you, for example, put two gloves, left and right, on a box, and you separate them miles away, and when you open the box and it's right-handed, automatically you would assume that the box on the left, on miles away, is the opposite side of the glove, or left-handed. If you open it here and it's right-handed, the other box is left-handed. So it just appears that they're communicating, but they're not. They already have a prior state. It's just hidden from us. Hindi lang natin nakikita. Yun yung counter nila Boris Podolsky sa EPR paper and ni Nathan Rosen and Einstein. Counter nila sa quantum theory. Now, pasok naman si Wolfgang Pauli. Si Wolfgang Pauli is an Austrian theoretical physicist, Nobel Prize winner din ng physics in 1945. Isa siya sa mga pioneers ng quantum physics. And now, nakisawsaw siya sa guloy. Sabi niya, why is Einstein talking about stuff prior to measurement? Aren't we, scientists, only deal with things that can be measured? How can he say that the prior nature ng particle is already has a hidden value when he wasn't able to measure it to begin with? Parang ganun yung logic ni Wolfgang Pauli. Ito yung mukha ni Wolfgang Pauli. Yan si Wolfgang Pauli. And it is untestable, Einstein. How can you test something prior to a measurement? Sabi ni Wolfgang Pauli. So example sa logic ni Wolfgang Pauli, let's say I say to you na I actually have a pink hair. It turns only black when you look at me. See? So we can't do any kind of experimentation if my claim is like that. You will say na, John, record a video of yourself na pink. No. The camera itself is looking at me. It's gonna turn pink when you look at it. Or I can even argue na, hey, I recorded it and I saw it was pink. It is pink. But when the moment you looked at it, it turned black again. So yan yung logic ni Wolfgang Pauli. Now, why are we talking about things that can be measured? And dumagdag pa si Niels Bohr na sabi dito ni Niels Bohr na hindi naman trabaho ng mga physicists ang alamin ang true nature ng reality. Natin yan trabaho as physicists. Sabi niya, ang trabaho natin is to find equations that will make accurate predictions for the results of measurements. Hindi ko na matagalog yan. Yun yung sinabi niya in English eh. And anything that is beyond that is not physics. It's woo. It's meta. It's something else. Maybe not woo. Maybe philosophy. And it's not me degrading philosophy, no. It's not science. It's not physics. So that's what Niels Bohr added sa sinabi din ni Wolfgang Pauli. So you can imagine na kontra talaga lahat ng mga quantum physicists kay Einstein. Einstein coming from a background na classical physics. Yun yung debate eh. Is our reality local? Na if I do something here, it won't affect something in a galaxy far away? Or is it non-local? Na ang pinaka-fundamental pala na nature natin, yung mga tiniest bits natin, can influence something that's galaxies away. And the nature is also fuzzy. It doesn't have some, yes, we have hidden values. Yes, it's deterministic. But it also has a property. Our known universe also has a nature na can be fuzzy. Can be both spinning up and down. Can be both spinning up and down. Let me repeat that. So may dalawang weird things that's currently observed now, that's currently happening now, na salungat sa kung ano yung na-oobserba natin sa nature, na salungat sa locality. That's why when in the first video I said na our universe could not be real. Real in a sense na yun. Real in a sense na when you do something, it affects in my local environment. In that sense. So it's not real pala kasi a thing can be both left and right, can be both up and down. A thing can communicate instantaneously. So it's not real, right? So our universe is not real. If pupunta tayo sa extreme. But that's what quantum theory implies. So yun, pagkatapos ni Pauly, sinabi niya yun, namatay na si Einstein. Si Pauly, sinabi niya yun around 1945 siya, 'di ba? So around 1955 namatay si Einstein. 1962 namatay si Niels Bohr. So ongoing yung debate, walang conclusion, pero mas nag-lean ang mga scientist kay Niels Bohr. Hindi nagme-make sense talaga si Einstein sa kanila. But there wasn't like an actual na experimentation that will put like a nail on the coffin na Einstein was really wrong. So here comes John Stuart Bell. So John Stuart Bell is a physicist from Northern Ireland. Siya ang originator ng Bell's theorem or the hidden variable na theory. In 1960 siya. So patay na si around 1960 siya. Patay na si Niels Bohr and si Einstein. And siya ang finally mathematically proved na Einstein was wrong. Non-locality is real. Non-locality is real, sabi niya dito. So ito yung nakakatakot eh. So the hidden variable na theory ni Einstein yung about the spin orientation na it's not spinning both up and down is wrong, because he was able to come up with a mathematical equation na you yourself can do. There's like you can search for the Bell's theorem and you can do your experiment yourself mathematically na hindi magme-make sense yung may variable na daw yung particle at the start. Ang magme-make sense lang is yung it should be both up and down as a value, not up only or down only. So yan, mathematically na-produce yan ni John Stuart Bell, and it should like close the debate, right? It should close the debate between Niels Bohr and Einstein. Kaso alam mo naman yung mga scientist ayaw nila ng mathematical na equation lang. Ayaw nila ng it moved forward, it was a huge leap to finally hinay-hinay na kino-cross out na talaga natin yung view ni Einstein. Pero marami pa ding loopholes. Marami pa ding scientists na pwedeng mag-argue na for example, another argument na pwede, it's an extreme na argument is the many worlds theory. It's a theory that will preserve Einstein's view na yes, locality is real. It's not non-local, and there is a hidden variable. It's not communicating. The particles are not communicating faster than speed of light. So the many worlds theory kinda like is a loophole to the quantum theory na view, which is able to communicate faster than the speed of light and able to have like a property that's both up and down or left and right. So yun. Even though meron na si Bell na ganito, there are still loopholes. And why are we talking about this? Is because recent lang nag-award tayo ng Nobel Prize in physics this year 2022, and this Nobel Prize is awarded to Alain Aspect, John Clauser, and Anton Zeilinger. And these brilliant people finally finally ruled out Einstein's view. They finally ruled out Einstein's view kasi tinapalan na nila lahat ng mga loopholes ng quantum theory. Non-locality is real. And this leap opened our world for a lot of things. Quantum computing. There's a term called quantum teleportation. What the fuck is that? It says it's not the Star Trek thing daw. But it's another name na naman ng scientist na ang sobrang weird na naman, quantum teleportation. Na tayong mga normal citizens will interpret it differently. But it's called quantum teleportation, quantum computing, quantum communication, and all. And in this era, in this time now, it's changed our view of reality. Na our tiny particles pala can communicate faster than speed of light. We don't know yet what is their mode of communication or paano nila na pull off yon. We still don't have any idea. But these three Nobel Prize winners were able to conduct actual experiments in a laboratory using Bell's theorem, using this guy, I forgot his name, Erwin Schrödinger. You remember the Schrödinger's cat? Using his work, sila ang mga scientists na actually nag-experiment, did an experimentations in a laboratory na Einstein was wrong, ruled out na si Einstein. Quantum mechanics is actually our reality. And yun. Aren't you scared?